So my name is Mitja Robas. I'm going to do the presentation on SDN. So what that is, the technology, what, let's say, you can expect of that, what is true and what's not true from the perspective of, let's say, what the vendors are saying and what you can see in the production environments in real life. And last but not least, also about the benefits and why you should think about the SDN and the, why you should actually deploy it. Or I would actually say that probably most of, well, you and also those guys that are not here in the next 3 years, they will see some kind of SDN in their environments, even if they go to public clouds like Azure. So, this is why I'm, let's say, standing today here to let's say, convince you, to tell you that the SDN is actually, the best thing that happened in networking in the last 20 years. The ultimate tool with which we can solve all the problems and issues. We can get rid of the networking engineers, or we can just keep, a couple of them. So yeah, it's absolutely amazing. It's really awesome, the SDN. So I may even say that it's sort of sexy, if you'd like. Like our beloved vendors say, with SDN you can do things with just a single click, which actually means that it's so simple that it's almost ridiculous how simple it is. So yeah, we're finally reaching the networking nirvana. So if we talk about the SDN and steroids, right? This is really it, the networking on steroids, like Arnold here. Now, as I've said, so I've been in this business, let's say, for 20 years, doing also the networking stuff, seen a lot of things. So in reality, thing is like this. So it's not really a panacea for everything. It's not, the solution for all the networking challenges. And well, with this, I could also say thank you for your, attention. Thank you for being here at this session. Don't forget to, fill in and provide a review for this session. And with this, I could actually finish the session. But let's say reality is something different. So this is what let's say I experienced when I started working with the SDN and with the projects with the SDN, deployment, designs, testing, and all that. So yeah, my perspective, let's say at the beginning, when starting with the SDN was, the one at the first or second slide. So yeah, this is really nice. This is something we've been looking for 20 years. But then you start learning, deploying it, then you start troubleshooting it, and you start seeing all the issues, let's say, or challenges that you can find in production. So the reality actually kicks in. So reality can be sometimes harsh, and that's why when you start working with new technologies and all that, probably you go through the same process like I did. So you go through the 5 stages of grief. The first thing is the denial. It's like, okay, I'm doing something wrong, right? It should be really the best thing that that happened in the networking industry for the last 20 years, so we can really solve all of our problems. But while you start doing things, while you start deploying, designing, and troubleshooting, testing, there is this feeling that you feel that something's missing or that something isn't right, like the data sheets and the vendors are saying. So yeah, the next stage is the anger, right? So you get really angry because at some point dealing with this and testing, deploying, and let's say you have version 1 products, and you dive into all the nuances and concepts of the SDN, which is something completely different and alien to what you've learned for, let's say, the last 20 years. Well, you become really dissatisfied with the SDN and whole idea. But then there's a third stage, which is bargaining, right? And you start thinking, okay, maybe I started with the wrong vendor and the wrong solution. Because quite frankly, there are a lot of vendors on the market, a lot of different solutions. They have some similarities, as we'll see a bit later, but when you start working with one and you get to the anger phase, then the next phase, is bargaining, and you start thinking, okay, let's try another vendor, because this one sucks, right? This one is the one that didn't do his or her job. And then I'll reach the networking nirvana. But yeah, you swap the vendors, you swap the solution, you swap the technology, I mean the underlying devices, hardware, software, whatever. You go to new version, but there's still something missing. So there's no way we can, reach the network Elysium. So it still doesn't feel right. So in the last phases, and this is why I'm standing here today, is the acceptance, right? The first slide said, yeah, it's a panacea for all the problems. Well, the truth is, it does solve real-life problems, a lot of them, but it's not really the only thing that we do in the network to solve the issues and challenges. Because, quite frankly, every day there might be a new challenge that you were not aware of yesterday. Yeah, so SDN is definitely something we need to think about and actually deploy, and it can solve the real problems, as I've said. So yeah, let's continue. So now, let's say we went through the process that I went through, and probably you go through the same process when you deal with different new technologies that you test in your environments. Now we can, buckle up and go on the journey, SDN journey, and try to enjoy it. Because quite frankly, it's still interesting, and it is interesting technology. So, before we dive into the, let's say, details and components, we also need to get rid of all the myths and misconceptions which are there out. And these are also technical and business-wise, and well, they root from the marketing and data sheet where, everybody's trying to sell you this new fancy stuff. Everybody's trying, or at least the vendors try to tell you that, yeah, we have the best solution, which is, by the way, SDN, the other vendors, they are not there yet. So let's see which myths and misconceptions are there and that need to be taken care of or dealt with. The first one is, SDN stands for software-defined networking. Truth is that hardware is really, really relevant, and the saying, or this is at least what software vendors would be saying to you, hardware is irrelevant. This statement is actually wrong. It is really, really important that you pick the right hardware, that the underlying beneath the SDN there is proper hardware doing proper things. And actually, some of the solutions of some vendors, they're more hardware-based than maybe software-based. So hardware is really relevant. And to those of you who maybe served the army, there was a saying that is gresa ne moraš narediti zrezka. So if you don't have proper hardware, your SDN just won't work. You'll have a lot of problems, a lot of issues. So it's not just like, let's pick some white box switches and let's bring them to our data center, or let's just pick whatever server and put our SD-WAN on top of it and start using it, because you will just face too many problems. So you will be stuck in that anger phase, I guess. Yeah, so at least that's true if you need to do deployment of the SDN in production, and I guess most of us have to do that in production. So why is hardware important? There are at least two things, but there are more than just two. But just for the sake of discussion, I have here two of things. The first one is compatibility. So software needs hardware to run. Like Azure, it's software. You put the workloads there, but beneath there's still some hardware. And trust me that Microsoft is also very picky of what they put into their data center so that it operates properly. So if the hardware doesn't perform like it should, the software will have problems. It's true that, let's say, all the protocols in the networking that we use, everything that's been done in the last 20 years is built in a way that it can work around the errors that appear. So if there are some packet losses and all that, but still, if you have a hardware that has some bugs in drivers and firmware and similar, you will have pretty lousy SDN environment, and you will have a lot of problems with your users, applications, and they will be really, really dissatisfied. So that's why, yeah, hardware is one of the things that needs to be properly not only sized, but selected, picked on that homework let's say, in that homework book for designing the SDN solution. Yeah, so let's go on. The second thing is performance. Why? Because SDN, as said, SDN is software-defined networking. So if I'm running things in software, and the network today is even more important and crucial because, you know, everything has to communicate. So if my network is not working properly because my software running on some hardware cannot perform, cannot forward all the packets, doesn't meet the latency requirements and all that, I'll have a lot of problems. And again, dissatisfied users, applications won't work. Maybe I'll even lose some business because of that. So yeah, it's really important because picking the right hardware is also very important because of that aspect. Performance-wise, because like I've said, you know, the first thing was, yeah, hardware is irrelevant. It's not. Hardware gives the juice to the software to forward the packets. Hardware is here responsible for forwarding, for moving the packets from input interface to the output interface to do the QoS and all that, and it can offload things from software and it can speed things up. And it's not only because, let's say, you need 10 or 100 gigs of throughput, but the truth is that, well, you know, latency, users are very picky and sensitive to the latency, so the applications are sensitive to the latency. And if you don't have proper performance, which means that if you don't, you know, select proper hardware, you will have increase in latency, so users will complain. Second misconception or myth is that any physical network will do. Yeah, I have a software-defined networking solution, like, I don't know, NSX from VMware. You know, they will tell me, you know, whatever you have beneath, whatever physical network, it will just do right. Truth is, it's not like that, because there are some requirements that the physical network has to meet. Things like throughput, things like MTU. So yeah, these are some of the, let's say, parameters that the physical network has to meet. MTU. Typically all SDN solutions do some kind of encapsulation of the packets because they build some kind of tunnels, let's say, across the physical network, which adds some overhead to the packets. And yeah, if you have applications that don't, you know, send large packets, it might be okay, but sooner or later you will face an application that will use, you know, a packet that's 1500 bytes large. And with the SDN, it adds some bytes to that, and if your physical network can't meet that, you'll have problems. You'll have packets won't be transmitted. So it's not just any network, physical network. Why is that important? Because let's say people build data center locations across and using connectivity from the service providers. And service providers may not or might not be willing to give you large MTU sizes or support on their links. So in that case, you have to be aware of that, and you have to adjust your SDN at the edge where you connect these two data center locations, or even if you go to the cloud like Azure. Next thing is bandwidth. Why is bandwidth so important? Because the fact is that when you start using SDN, because you're abstracting your topology that your applications and users are using, that topology is on top of physical network, and they don't map exactly the same way. The thing is that, you know, I'll build logical connections between two nodes, which and in reality, this packet might go a couple of times through the network, which means I may need 4 times the bandwidth for a single packet, or 3 times, or maybe even 10 times. So I need more bandwidth, definitely. Next thing, topology. Physical network, as I've said, so typically with the SDN, and I can vouch for that because we did a lot of projects, as I've said, the traffic won't go from one, let's say if we just focus on the data center and the switches there, it won't go from one switch to another switch, but actually it will go maybe from this to that, here and there. So if I do full mesh of connectivity, I'll have a lot of problems when I'll have to troubleshoot. SDN on top of the physical network, because all of a sudden I could get loops underneath. Above, the SDN looks happy, but underneath I have loops and my SDN is not working. So typically with the SDN solutions, well, you need to adjust also your physical network topology if we talk about the data center stuff. So yeah, that was the second one. The third one, that's my favorite, is you just need one click and everything will work, right, with SDN, because it's all built in. All the automation you need from day one is there. It's like the IKEA, right? At least my experience with IKEA is that it's not always that simple to put things together. So there is work required when you want to design the SDN solution. It's not just like one click and just out of the box and all that, because it's just not like that. Simple. You need to design it, because there are things like, as we'll see when we get to the part where we talk about the components, you have a thing called controllers, and they're used to, you know, to tell the nodes, the networking nodes in the SDN network about the reachability information. So if I don't properly design, let's say, the place where my controllers run, I'll have a lot of problems, because my reachability information in the SDN just won't be there maybe, or it's going to be wrong, or you know, someone might attack it and I don't know, impose something or stuff like that. So design is really, really important. The second thing, like I've said, because you have to design and look at the physical network also, well, you have to also do the design for the physical network. If we're talking about the data center network, even if you go to cloud like Azure and you're using SD-WAN, which is also software-defined networking solution, you still have to think about how you're going to connect to, for example, Azure or something like that. Do I have enough bandwidth? How am I going to measure these things and all that? So design is something that still needs to be done. Implementation. It's not like, you know, that you just buy something like those tents, you press something and all of a sudden everything gets up and running. You have to implement it. It might be easier from a perspective that if you have, let's say, a large environment, you don't have to go to, and again, maybe in the data center environment, you don't have to go to each and every of the ports and switches and configure all of that, because you do that from some central point, from orchestrator manager, as we'll see later. But still, someone has to implement that. Someone has to do changes to the config afterwards, after the initial deployment, because users will have, you know, new requirements, new segments, or whatever. So someone has to do implementation. Yes, there is some level of automation built into every SDN solution, because, as I've said, you don't have to deal with each and every of the networking nodes, but you still have to build the policies, you have to build pools and stuff like that. And the last but not least, and really, really important, is verification. Someone has to verify that when you connect workloads to your SDN network, whatever that is, in the data center or in Azure or whatever, it really works like expected. And it also works that if something fails, that it will still work. So, you know, you have to do all the crash tests and all that, because quite frankly, you don't know what can happen. Because at the end of the day, every, you know, software, every hardware has some bugs, and it's better to test and better to be ready and all that than sorry later. And of course, you could, it might have happened that you did an error in design, and that might, you know, come out when you do the verification, the testing. So, you know, getting rid of the networking engineers, it just doesn't work. Next thing, it's self-driving, which means, you know, I need just one guy that's going to look at some dashboards, tell me when there is alarm, and just click something, and you know, all the problems will go away. Right. You still need somebody. I mean, you still need skilled personnel to do the day 2 operations. What are day 2 operations? You have to manage it. Like we said, so, you know, you need someone to, I don't know, add something to the config. Maybe delete something from the config. And it doesn't have to be manually or through some kind of a GUI. You might have some kind of automation environment or a tool or whatever, orchestration tool, but you have to tell maybe the software guy what the software guy needs to program to achieve that through some self-service portal or something like that. So you need someone to manage it. You need someone to monitor, because you just cannot, leave the network to work on its own, because there SDN is, if you look at it from the bird's eye perspective, it is simpler in the sense of that it's much quicker to deploy new segments, it's much quicker to change things, the config, all the stuff. But under the hood, things are complex, so it's not easy. So it's easy on a certain level, but then you need someone that understands all this stuff, that when the troubleshooting needs to begin, that he or she can really do his or her job. And the next thing is that depending on the SDN flavor, the solution, the vendor, there might be different things and nuances that are, some kind of, some maybe unique to some vendor solution and are not present in the other solution. Maintenance, don't forget about that. SDN is software defined, which means we're gonna do software upgrades. And we're gonna do software upgrades much more frequently than we did that when we had more, let's say, hardware based. Even though, the switches 20 years ago, routers and all that, they used the software. But maybe we didn't do this upgrade so frequently. We just did them when it was necessary with the SDN, because that's also one of the benefits of the SDN. You deploy a new version, you get new features instantly. Of course, you have support contract and all that, but that's the other story, let's say. So you have to have someone that does the maintenance and properly, which means that everything has to be operational 24/7 or whatever. And you have to do the maintenance, upgrade software, maybe add a node without disruption, remove the node because something has failed. Someone has to do that properly. How you do the maintenance also depends on how you did the design. So if you design things properly, high availability or let's say redundancy, resiliency, that will affect the maintenance, because if you haven't done, or if let's say a CFO was stingy when you designed the network and you couldn't deploy proper level of redundancy, then doing maintenance might require having maintenance windows. If you are allowed to do things properly, maybe you don't need maintenance windows. Let's go on. So the fifth myth or misconception is it's programmable. I'm not saying it's not. It definitely is programmable. And you got APIs. And actually it depends on the vendors how they handle this and what do they expose. The thing is that you have the issues with the versions, right? I have an iPhone here, so you go from version 6.2 to version 6.3 and they deprecate APIs. And you have your orchestration system relying on the API calls. So that's also part of the maintenance, and when you do the upgrades, this process and everything that you have to plan, you have to anticipate that. And be aware of that. And it's never done deal like with any software. So versions are important, right? And this is not, by the way, this is not from my private collection. I didn't drill the hole to get the audio jack. Features, API. It depends on the vendor, to be honest. There are vendors that, let's say, expose all or most of the features through the API, which means that you can use the API to do the automation. There might be, or there are vendors that actually don't expose everything through the API, which means that it's not that programmable as you might think at the first, right? Because we said at the beginning, vendors say, it's the ultimate solution? Well, like I've said, so you maybe did the design, you did the implementation, you're happy with that, and then you go to the automation part because you want to have self-service portals and all that stuff. So you want to speed up things. And then the software guys come back to you and they tell you, sorry, we cannot do that because there's just no API. I cannot call something to, I don't know, deploy a network segment. So that's something that needs, that's also part of the homework that needs to be done maybe in the design phase or even in the phase before when you, decide and select which SDN solution you should use. So, and last but not least, and this is my favorite, stretch layer 2 is now okay. No, sorry. Stretch layer 2 between locations, between the public cloud and your on-premise location, it's never a good idea. Yeah, you get rid of spanning tree stuff and all that, but you still have problems, and the problem is called split brain. If something cuts the link between the two locations or cuts the link between your data center location in Azure and you're using the same IP addresses, public, private, doesn't matter, but the thing is you're stretching your IP subnets, something in between cuts the connectivity for whatever reason, you all of a sudden have a split brain problem. And SDN doesn't address that. Yeah, okay, addresses the pitfalls of the old protocols, like the spanning tree, maybe some kind of routing and all that, but it doesn't, it's not something that gives you the, I shouldn't say right, or gives us the right to use this. This is really a bad thing, because, yeah, like it says, right? Just because you can doesn't mean you should. So, I'm just going to repeat this more quickly. So we said there's, okay, I've listed 6 of them. There are actually more than that. We said hardware is irrelevant, myth busted. Any physical network can do? No, not really. It's super simple. I probably scared you off by now, and it wasn't my attention. Things will get more clear, but it's not that super simple that they're trying to tell us. It's self-driving, so we don't need anybody, right? Like self-driving cars, and then they crash. Programmable, yes it is, but do check what really can be, automated and whether or not it's available and all that. Ask the right questions when the vendors tell you that it's programmable. Ask, specific question, can I do this and this, and then you can see. And then if they tell you, yeah, that's going to be in the next version on the roadmap, maybe it's maybe it's good to reconsider, or maybe you should wait for the next version. And stretch layer 2 is okay. No, never. So now to more bright part of the SDN. Now we can talk about what SDN is, really. What's built off, what's the definition? The truth is that if you, look through the data sheets, browse Google and everything, it really depends on the vendor what they will say that SDN is. Because at the end of the day, they need to sell us things, right? So one of the business drivers also for the vendors, but it's not only that, is of course that with the SDN, you go mostly to the subscription-based model, like with the software, right? It's not like you buy it once and just have it, but you pay the subscription, which is nothing wrong with that, but that's also one of the things. So like I said, yeah, many vendors, many flavors, many definitions, and this compromise here that I have on the slides is actually what is my take on the commonalities of the SDN. So first of all, these are the requirements that drove, let's say, the development and the products that vendors have of the SDN. So yeah, everybody wants, at least the networking guys, feel that. Everybody wants infinite bandwidth, which means I don't want to ask for more bandwidth, I just need the bandwidth. I want infinite reliability. So I don't care if the link failed, I don't care if the port failed, I don't care if the switch failed, I don't care about the network. It just should work these days, right? No downtime. Yeah, and I really, and that's users and applications, they really want predictable latency, right? It's nothing is wrong, let's say, if the latency is like 5 milliseconds, if it's, let's say, constant more or less. But if it's under 1 millisecond, and then all of a sudden it goes to 20 milliseconds, that's what we feel. It's 20 times slower. And because it's 20 times slower, the user will be disgruntled, and yeah, you get calls and all that. Seamless mobility, right? Moving the workloads between the locations into the Azure or AWS or whatever. So yeah, I just want to move my workload. That's the requirement. I don't care about reachability information. I want to move my application there, and then I want to pull it back. And I don't want to do a lot of things to be able to do that. Multi-tenancy. Even if you're not a service provider these days, multi-tenancy is something that people do require, because you have different departments, or you have different applications, or usually what we've seen is you have a test, production, development environment, which is proper way of developing applications, or even if you're not developing applications, putting the applications into production, because you need to test them somewhere. So all these are requirements. The technologies in the SDN, there are a lot of them, are, for example, the underlay network, as I've said. Typically in the data center, let's say, this would the topology and the technologies around that would be something called leaf and spine. So this is the way how you build a network in the data center. Overlays. Every SDN solution uses some kind of overlay. There are standards, like in the data center, VXLANs. Well, some use Geneva encapsulation and so on, but point is there is some kind of tunneling. A coworker of mine did an excellent job, I don't know how many years ago. We could probably call that SDN also, because we replicated that design, I don't know how many times, in wide area network. And it was GRE tunnels or IPsec or MPLS with routing, but it was it was really nice solution. The thing is, that was sort of an SDN in terms of that it used the overlays and all that. But yeah, let's move on. NFV, so virtualizing the network functions, whether it's depending on the solution, whether it's in the hardware, distributed firewalling, or it's a virtual machine that is the firewall, or is the router, or a host with a kernel module that does the filtering, whatever. But the thing is, the network functions are virtualized. They might not be on a specific dedicated box, the hardware that you pay a lot of money for that real estate. Central controllers, that's something that all typically share. That's what I already mentioned. So a set of, it could be a VMs, typically it's VMs, that keep the reachability information and other stuff, and they give this information to networking nodes, so they can, that the endpoints, the workloads can actually communicate when they move. This is how we also get that, what was that? Seamless mobility. Programmability, we mentioned that, and automation. There's some built-in, but the SDN actually does enable, proper SDN I should say, does enable the use of automation. You can do you can program it really with the proper, let's say you can use PowerShell, Python, Ansible, vRealize, I don't know whatever. Well, a lot of things are out there. So, let's say, what are the components of the SDN solution? There are three, let's say, planes, we call them in the networking. A management plane, control plane, and data plane. A management plane is where my manager, orchestrator, or whatever the vendor calls that part is located, and this is the point through which, out of the box, I do the config. It usually has some built-in web browser, web server, provides me a GUI through which I can do the config. Every SDN solution has something like that. It's also the point through which API calls are, forwarded to the networking nodes to do something, to deploy, I don't know, a new network segment. So it's quite important, but the thing is, because it's the management plane, the traffic doesn't go through this plane, doesn't go through that, let's say, VM. If I lose that, I only lose the ability to change the config, and I only lose typically, if it's proper SDN solution, and I only lose the ability to do the config changes and to see what's happening. So in a sense, it's critical, but not that critical. Control plane, this is typically a set of controllers. Most of the solutions have 3 of them. Voting mechanism, they share some fate, they take care of the reachability information, which might be, let's say in data center, that those are MAC addresses, tunnel endpoint addresses, ARP cache, all this stuff. So that's reachability information. Still, the control plane, the controllers, this is not something through which the traffic goes. Traffic actually goes through the data plane. A data plane, what is the data plane? It actually depends on the SDN solution. So if you have a host-based SDN solution, which means that the networking happens on the host layer, for example, on Hyper-V, then the host is the one that does the encapsulation, decapsulation, forwards the packets, and so on. Does the address resolution based on the information given from controllers. If this is a, it could be an SDN, it could be a virtualized network function, and I could have a virtual router. Then in that case, yeah, the traffic goes through that virtual router, but that's still the data plane. So this is the commonality to all the SDN solutions. Every SDN solution is built in some way with these 3 planes. Next, what I already mentioned was that how the endpoints communicate through the SDN. Again, this is just an example of the data center network, and you see a thing called a VTAP, or let's say more general term would be TAP, which is tunnel endpoint, which is nothing more than an IP address that my networking node uses to so networking node encapsulates the traffic, the packets from the endpoint, puts them in the envelope, and the source and destination to go through the network is a tap of my own and the tap of destination switch, let's say in this case. In SD-WAN, it's very similar. The only difference is that I don't have switches there. I might have virtual routers or physical edges, whatever, a gateway to Office 365 or gateway to Azure. But the point is that there's something called TAP, which is basically an IP address typically at which the encapsulation is happening. So yeah, overlay networks are used within every SDN solution. What kind of encapsulation actually depends on the vendor and the solution. So there are standards. VXLAN is a standard which is used in data center, mostly by the vendors, also implemented in the physical NICs. So if you need, virtualized, let's say, routers that could use offload the traffic processing to a NIC, that would be the case. There is another encapsulation that's not, it's standard, but not that widely used yet, Geneva. And then typically the SD-WAN solutions use their own, most of them use their own proprietary, some kind of proprietary encapsulation, or IPsec or something like that, or SSL, which is sort of, added, something is added to address also the quality of service stuff and things like that. But the point is, there are overlays in every SDN solution. Tenants, we mentioned the tenants. So yeah, because we have the SDN solution, because at the end of the day, even if it's hardware-based, I do configure my environment through software constructs. It's really easy to do the tenants. Tenants meaning, like I said, easy to do the production environment, to do the development test environment. I could easily do something like that. I could have a development environment, which is where my internal developers are developing a new application. And at that point, I don't need test and production environment because the application is not ready for production, let's say. Next step is, of course, I need the test environment, right? So I could Because it's SDN, I could take what I have in dev environment and I could just, clone it to a test environment, or I could promote the dev environment to test environment and then to production. The point is that I can really do this quickly. I can really do this easy. I don't need to do rewiring. I don't need to, unless, of course, like I've said, the SDN requires proper hardware and resources. So when you are building, adding stuff, you might, reach the limit of your physical hardware resources, CPU, memory, or whatever. So at some point, it might be necessary to add another node host for hosting your, SDN and all this stuff. But that's not a problem because you can do it like that. Okay, overlays. We said. Before we continue, which is very important, is that whichever solution you're looking at and vendor, don't expect that solution by itself will solve your problems. You have to understand, and whoever talks to you has to understand what the problem is, what is the issue, how it can be solved. And as I've said, because SDN actually is, sometimes it requires us to kind of forget what we've learned for the last 20 years about networking. You have to think about different concepts and use them and do that differently. So, a couple of solutions listed here for the data center, for the WAN, even for the hybrid cloud. There are more than just this listed here, but it's, let's say, some of them are here. When you start also thinking about the SDN solution for your environment, it's good to also think about the similarities and differences between the different solutions that you're looking at. Because not every solution will tackle the problem in the same way. You have to step back and think from a perspective like, how I'm going to do the redundancy, resiliency, what are the scalability limits? Because maybe today you're not thinking about that because you didn't have to, but maybe tomorrow the number of VMs will increase and you might hit the limit. So these are the things you really need to look at and think about. Yeah. Like we said, design and deploy. This is the homework that needs to be done. So with the design, it's infrastructure that we need to size and design how it's going to be connected, how many resources we have and all that. Once we've designed the infrastructure, we also, in part of the design also to think about how your workload is going to be connected, Typically, you want to have it multi-homed, at least to 2 different connection points to provide proper redundancy. What does that mean for the workload? Am I going to use active-active interfaces or active-passive or what? 2 IP addresses, whatever. But this is something that needs to be thought about. And how I'm going to interact with the external world. Because, at some point there is an edge to the SDN solution. So there I need to go to the old classical network and I need to interface with that. So where do I do that? How do I do that? How do I do that reliably and with enough performance? On the other side, there's deployment. Yeah, every SDN solution needs the bootstrapping. So I need to, set all things. I need to install physically or software, connect all those dots. So then I'm ready to start deploying. So for the second step, which is actually the implementation, and I'm connecting my workloads and migrating my workloads to the SDN solution. And the third thing is, like I've said, the ongoing changes that I need to do on a regular basis. One thing to remember and not to forget, SDN, it's really nice, as I've said, it has built-in automation, right? Think of this, I have 100 switches in data center, let's say, and I need to deploy policy on, let's say I have 100 switches, 10 ports at each switch, so that would be 10,000 ports I need to configure with the same config. With the SDN, it really is, let's say, 5 clicks and some parameters that I put in, and I have all the ports ready and configured. It goes also the opposite way, right? If I mistakenly delete something, I'm going to nuke my world. In classical network, if I did a mistake on a single port, it was a local error, right? Here, when I delete a policy that needs to be applied to 10,000 ports, I might have disconnected everything. Point being that, like I've said, the operations, data operations, maintenance, management, it's really important to properly address that. Because, yeah, you can nuke the world. And this is a career-changing, let's say, event. Okay, an example, Cisco ACI, I won't go into details. If you want to ask me, you can find me later or, on LinkedIn or whatever. It's a data center networking solution for doing things that we already discussed. So yeah, all the programmability, overlays, controllers, all that stuff is there. And all the things that we mentioned are also important here. MTUs, we get almost infinite bandwidth. You can never get infinite bandwidth because there are limits. But still, yeah, you get a lot of bandwidth. Second, for the WAN, for example, VMware's SD-WAN, there are also others, as I mentioned. This is just an example. I'm not saying that one solution is better than the other. It always needs, you always need to consider what that means to you, also from a perspective of, I don't know, licensing at the end of the day. But the point is, you can see the similarity. There's the orchestrator, which is basically a manager. There are some edge devices, gateways, so these are the networking nodes and all that stuff. And we get to the point, why SDN, right? So, we've seen the myths and misconceptions. Hopefully now your spirit is up in terms of that SDN is not that bad, but you got the real view of what SDN can do and what you need to think about. And now let's see, why SDN, right? Like I've said, you can really get rid of tedious tasks. So, imagine you have to configure a lot, even if it's not 10,000 ports, even if it's only 20 ports, because you're adding the network segment, or if it's like, I don't know, 20 hosts, then you need to deploy a segment. With SDN, you create a policy, you apply it, and that's it. Which means that if you properly designed it, you have it like that, and it's less probable that you will do an error in terms of that local small error, because local small errors, they build up if you create them on many places. Let's say you have to configure 100 ports. Definitely you'll make at least 10% of errors, and that's hard to find. With SDN, if you did your configuration or homework properly, you will deploy it, and it's going to deploy all over the place properly. Of course, if there's no bug, yeah. But they're not that frequent. And scalability, it's much more easy to increase the performance, the throughput of the SDN solutions. Like I've said, if it's really more SDN than hardware-based, this only means that you might need to add an additional node with CPU and memory resources, connect it to the network, take it into the SDN pool, and that's it, and you're done. And the same way you can decrease if you don't need that many resources. And the same goes in the public cloud, because you deploy your virtual, routers. If you don't need them, you can just dispose of them, and you stop paying the subscription, which is when you buy a hardware, it's hard to get rid of because you bought it and it's there. It's real estate, you cannot get rid of it and nobody will buy it. And changes are really fast, yeah, they're really fast. So like I've said, doing a change, because there is a built-in automation, is really, really fast. One thing which is, again, also very important, which we already mentioned, is that you can really easily and really, the speed of redeployment and redesign, it's fabulous. It really is fabulous, because this is an example from one of our deployments that we did, 4 or 5 years ago. We started with a simple design. In 2 days' time, we went from what's on the top left corner to what's on the bottom left corner. So the complexity in terms of how we did deploy our tenants and everything really increased, but we didn't have to do any kind of rewiring. And which is more important is this: we didn't have any downtime doing this. Because we were able to do that on the fly, change the topology and everything without affecting the users and anything. And that's really beauty of it. That's why it's called the SDN. So once you get into this, you can start thinking about, even from the networking perspective, start thinking about the applications, how they communicate and everything. Because I didn't mention, but one important thing and part of the SDN is also the security. You can offload a lot of things to the network, and your host or network nodes can do a lot of security stuff within the data center, the edge, or whatever. And if you start focusing on applications and you create the application traffic blueprints, profiles, this can be easily translated into the security policies, and with the SDN you can deploy it faster than any kind of firewalls that you would have on many places. And last but not least, as I've said, automation. Really, proper SDN solutions have, let's say, I'd say 90% of the things they can do available through the API, or more, 98%, let's say. So you can automate those tedious tasks. So even when you need to add, let's say adding a network segment in an SDN solution might mean that you need to create a policy that gives an ID for the segment, names the segment, connects the segment to some logical router, updates the routing so that it forwards the information, and so on and so on. You could do that manually each time, or you can automate that because it's really easily can be automated. Okay, we've come to the end of the let's say discussion. I didn't want to give you a wrong ideas in terms of the SDN is bad. I wanted to give you a proper overview of the SDN in terms of, yes, it can solve a lot of problems, issues, challenges, and if you use it in a proper way. My summary would be this. The first thing is very important. Yeah, hardware is really, really important. It's not just software. Design, don't forget about that. It's absolutely, you can't go without design. Don't take any shortcuts, because shortcuts will get you into problems later. Meaning, I don't know, you undersize something, or you don't think about how the naming convention is going to be done, and then later on you figure out that it's all wrong and all that. Maintenance, really, really important. It's not a fire and forget project. And automation, and at the end it's all about delivery. So, meaning that, design implementation. It's not out of the box. It's not just, self-driving and all that. It needs some work. That's about it. That's something about me, but I won't go through that. If you have any questions and all that, you can find me later at outside, or shoot an email, find me on LinkedIn. That's it. Thanks.